the second section in chapter 10 here. We're going to talk about the inner planets. Now that we've got some of that background of how the solar system works, and we didn't go into a great deal, granted, but we went into enough detail that we can move on here to looking at the planets. And we're going to focus on the inner planets here. And the word planets actually means wanderer. If you remember, I talked about how the ancient, well, we would refer to them as ancient people, but they looked up in the sky and they saw some of the stars or the objects in the sky moving differently. Well, this caused them to use the term planet, which meant wanderer, to describe some of these. And at that time, well, not the first time, but the ancients actually discovered and identified 6 of the planets, 3 other inner planets. Earth is in there. And count Earth as one of them, and then there are 2 outer planets, Jupiter and Uranus, I believe. No, Jupiter and Saturn, that's what it was. Because those are 2 of the largest ones, kind of makes sense that they might have seen them sooner. So we're going to start from the inside at the very closest and go outward. Mercury is the first planet. It is the closest planet to the sun. It is the speediest planet, meaning it has the shortest year. One of the longest days, though, because it turns so slowly, it takes quite a while for it to actually make one revolution on its axis. And that's why it got the name Mercury. Mercury was a messenger to the gods. He was known. One of his attributes was speed. It's also one of the smallest of. It is the smallest of the 8 planets. Let's see. Every 3 to 13 years, Mercury's orbit travels in front of the sun as seen from Earth, allowing observers to see Mercury as a black spot against the sun's appearance. Travels at roughly 30 miles per second. Mercury was the Roman god. Has an 88 Earth day orbit. As it orbits the sun, Mercury slowly rotates on its axis, causing one rotation every 59 Earth days. But because of Mercury's slow rotation, it actually is almost 2 years for it to actually have a full day, a period of light and a period of dark on a spot on its planet. It varies in distance from 43 million miles to 29 million miles. Because of Mercury's orbit and period of rotation, the same 2 regions on opposite sides of the planet take turns enduring the high noon sun at Mercury's perihelion. Because only these regions experience the sun's greatest fury, they are called Mercury's hot poles, since it is so close to the sun. There. The second planet is often called Earth's twin. It's pretty close in size. It's significantly further from the sun than Mercury, but not all the way out here to Earth, obviously. It is often the brightest object in the night sky, other than the moon. It's so bright, as a matter of fact, that Venus got the name day star because it could be seen in the early morning hours when the sun was up, and it was the only star that was seen at the time. Typically seen around sunset or sunrise. It earned the name morning and evening star. Forgot to mention the evening. It's the only planet that takes longer to rotate on its axis than it does to orbit the sun. Venus was 55 days to orbit, 88-day year from Earth's perspective. Venus, on the other hand, each orbit around the sun takes 225 Earth days, while one rotation of Venus requires 243 Earth days. So it rotates very slowly. Venus's rotation is backward from east to west. Thus, the sun on Venus rises in the west and sets in the east. Due to its revolution and rotation, Venus takes 117 Earth days to go from sunrise to sunset. Or sunrise to sunrise, sorry. Because Venus and Earth are similar, including density, mass, gravity, and size, Venus is only a little bit smaller. It's often called Earth's twin. And it is the hottest planet, not because of its location from the sun. Otherwise, Mercury should be the hottest planet. But what we see and what's in the picture here is Mercury is covered by gases. That's not the surface of Mercury we're looking at there. We've developed technology that penetrates the clouds. You could go online and see pictures of the surface of Venus. This picture is not one of those pictures. This is of Venus as it looks like if you were to take a picture from space. And it has all these clouds and it's got all these gases in its atmosphere that just trap heat. Let's see. In the 1990s, astronomers used an unmanned spacecraft to make radar images of 98% of the surface. At Venus' surface, the atmospheric pressure is about 1,330 pounds per square inch. Its upper atmosphere is more than 95% carbon dioxide. Earth's atmosphere, by contrast, is only around 20 to 21% carbon dioxide. This traps the heat of the sun, giving temperatures of over 860 degrees Fahrenheit or 460 degrees Celsius. Nighttime temperatures do not drop much lower than the daytime temperatures because that heat is just trapped. It cannot escape, does not get out. Probes that land on Venus can only work for several hours before the harsh atmosphere ruins them, and part of that's just the heat. Our planet Earth is situated in where we can build stuff and utilize it within the temperature ranges, the average temperature that we find here. The average temperature on Venus is so much hotter that it's going to fry computer chips. It's going to melt plastic. It's going to ruin a lot of the things we use as structural components for these probes, so they can only last for a short period of time, which is why it was such a big deal back in the 90s when they had a probe orbit Venus, and they were able to use technology to penetrate the cloud cover and get a actual picture of the surface. It was probably the most complete picture we've ever taken, and if you go online, those are probably some of the pictures you'll find pretty quickly. Venus's intense temperatures are hot enough to melt lead, and it only takes, if I remember my days working with lead right, a little over 600 degrees Fahrenheit to melt lead. Which brings us to the third inner planet, ours, Earth. Now, we're not going to spend a lot of time on Earth. I have a fun picture and stuff as we switch sides here. Average distance from the sun is, if we're rounding down, 93 million miles. Only planet in the solar system that sustains life. We have not discovered life or even life signs on any other planet. Moon is the Earth's only natural satellite. A satellite is an object that revolves around another object, which can be man-made, such as our communication satellite, or a natural one like the Earth's moon or any of Jupiter's moons, any of the other moons out there. The lunar month is a little under 30 days, 29 days, 12 hours, and 44 minutes. The dark patches on the moon are called Maria, which is Latin for seas, because when early people looked at it, they thought it was actually oceans where water would be. We now know that that, of course, is incorrect. There are rays. These are light-colored streaks radiating up to thousands of miles away from the craters on the moon. Again, if you look up pictures of the moon, and actually I might be able to see it on the picture. Not really. But the rays are radiating out from the crater there. Those are pretty much, the Marias and the rays are pretty much the only two significant structure or geographical features of the moon. I don't want to say more importantly, but of more interest, of a lot more use to us here on Earth, are the phases of the moon. And I have them listed up there. New moon, the sunlit side of the moon is turned away from the Earth and completely hidden from view. And you can see this in the diagram at the bottom of the page. That's when we can't see the moon. The waxing crescent, we start seeing more of the moon. On the diagram at the bottom, it says young moon. You see just that little sliver. Waxing crescent, a little bit more there, more like the fingernail that people talk about. Waxing quarter, when half the moon is visible, it's called the quarter moon because it's a quarter of the way through its phases. That's why it's called the quarter moon. Waxing gibbous is when it's more than halfway visible, but not all the way visible. Full moon, the entire face of the moon is illuminated. Waning means to gradually decrease or waning, gradually decrease in size. The waning gibbous, again, we have that not entire, but more than half. The third quarter, that should be IR, not RI. Third quarter moon is, again, half the moon showing. Waning crescent, that thumbnail sliver, and then old moon, again, just a little bit of a sliver. Then it goes back to new moon, and the cycle continues on. When the months of the calendar were first initiated, many of the systems were based off of the phases of the moon, which is why most of the months were originally between 28 and 30 days, or really close to that 28-day counting there. And a lot of the lunar calendars have 13 months in them because of Roman emperors and other kings and stuff. They took days away from one, reorganized things. And we have our current 12-month system with various days throughout each month. So there you go. With the moon, it gives us a very unique phenomenon called an eclipse. Now, some people might say it's coincidence or interestingly enough or whatever. Other people have pointed to it as one of the facets that uh, makes our position in the universe rather unique. Our moon is exactly the right size that when it eclipses the sun, it actually allows us to learn things about the sun, especially before a lot of modern technology. The solar eclipse, the moon moves directly between the sun and the earth, blocks part or all of the sun from our view. Kind of depends on where you are when it happens, how much of the sun is actually blocked from your view. When a solar eclipse is about to happen, they will talk about the best viewing places, which are usually kind of in weird places. It's extremely dangerous to look directly at the sun. Don't do it. It'll mess up your eyes. And partial solar eclipse when the moon covers only a portion of it. And when you see in the bottom left picture, that's a total eclipse. You see this little ring around where you see some effects of the sun. And like I said, with the moon, it is the right size and the right distance from the Earth to the sun to block out the harmful part of the sun during a solar eclipse and allow us to observe a lot of things about the sun and to understand our sun. If the moon were any other distance, it wouldn't be as good. If the moon were any other size, it wouldn't be as good. It is just right for this. Lunar eclipse is when the full moon passes through the Earth's shadow as diagrammed on the right there. And again, depending on where you are, depends on how much of a lunar eclipse you will observe. This one, it's not as wide-ranging as the solar eclipse because the moon is closer to the Earth. It just has to be on the other side of the planet. It's why it happens fairly frequently because the moon rotates around or orbits the Earth. So the Earth is going to be between the moon and the sun at some point during that rotational period or that orbiting cycle. Mars, the last inner planet, also known as the red planet because it does have a distinctive red coloring. You can see that red coloring through even a fairly inexpensive telescope. I have kind of a fun picture here taken. That's not a true to photo. It's using some technology there. It is the last of the four inner planets. It's roughly half the size of Earth. It has two moons called Phobos and Deimos. I think I said that right, Deimos or Deimos. And it has the largest known mountain in the entire solar system. It's kind of interesting how these planets and stuff got named. Most of them are Roman gods. Mars was the Roman god of war. It has that red color, made people think of war. And I believe Phobos and Deimos are sons of Mars, if I remember right. And so when they discovered the moons around Mars, it just kind of made sense to keep going with the mythology and the naming there. And it is pronounced Deimos with the long E sound. Let's see, yeah. And actually, Mars's moons were named after the Greek god of war, even though the planet was named after the Roman god. Make sure. Yeah. So, yeah, it goes on. Mars, we've put robots on Mars. I saw something on the internet. Mars is the only known planet to be completely inhabited by robots. Like I said, no known life, but we've sent robots there, several as a matter of fact, to map it, to look at it, to get details. Because of some of those robots, it's believed that there is water on Mars, just not in the form of a liquid, most likely in the form of ice. And actually, at the ice cap, or at the polar ice caps, Mars does have some. They're noticeable because their white color stands out against the red sand. These ice caps consist primarily of a thick layer of water ice with a thin layer of dry ice, frozen carbon dioxide on top. Through the seasons, the polar caps shrink and grow. It's thought that they don't just melt, that they sublimate when they do because of just the difference in temperatures when it happens. Let's see. Besides the ice and the polar ice caps, there's also frozen water under the Martian ground, again discovered as a result of robots there, some of the probes we've sent. There's also a small amount of water vapor in the Martian air. This sometimes forms cirrus clouds and ice fog. Not very common occurrences by any means, but they have happened. And that brings us to the last of the inner planets. The next section will deal with the outer planets, and we'll talk about those. So go ahead and answer the science video question, and we will meet again.